there everybody, and welcome back to the next episode of our Fusion Zero to Hero. Today we're going to be looking at machining toolpaths, so specifically looking at creating and machining the component that we have on screen at the moment, so the part that we've been designing over the last few episodes. So just as a quick overview of what's coming today, we are going to be looking at various toolpaths and strategies that we can apply to a component like this. For the most part, quite a few of them are going to be within the toolpaths themselves, are going to be available within the manufacturing extension, just as a caveat to begin with, especially for a component like this. But the principles are going to be much the same for strategies that are not. So Fusion does have a machining extension which extends the functionality of the machining environment. Within the base Fusion installation and licensing, we have full access to 2D and 3D strategies. 2D strategies will look at a 2D element, a 2D input, and allow us to define exactly how we want to machine that, whether it be a contour that is then increasing the number of passes in the Z, or whether that be machining a pocket, and we essentially just choose the profile of said pocket to be able to machine that. That's functionality that is straight back in the base installation and licensing of Fusion. However, where the component that we're looking at today is obviously a little bit more, requires a slightly more intricate toolpath, especially looking at some of the three, or in this case, I suppose, a bit more 4-5-axis functionality. So anytime you're looking at additional functionality like the 5 and 4-axis machining, especially simultaneous machining, we will require some of the extended functionality. With that out of the way, we'll go through the process and toolpaths that we'll be looking to implement on this component when we do go to the manufacturing facility, and just give an overview of what we're hoping to achieve from within there. So in order to start adding these toolpaths in, we will need to be inside of the manufacture workspace rather than the design workspace where we've been in up until now. So you can see in the top left, I'm now within the manufacture drop down, or the workspace drop down, selecting the manufacturing or manufacture workspace, whereas previously we were in the design. So selecting manufacture in here will bring up the manufacturing tools that are available to us, and these are then broken down into tabs containing milling, turning, additive, and inspection, strategies and tool sets and that, and then we've got utilities and fabrication as well available to us. Keeping to the same principles though within the Fusion interface, we're generally working from left to right as we go through. So any time we are manufacturing inside of Fusion, we want to create a setup to tell the machine how we're going to be running this manufacturing of the component, whether it be milling, whether it be turning, additive, and so on. Basically, the setups then contain all of the information, not only about the component that we're wanting to machine, but also how we're wanting to machine this or manufacture this, whether we are wanting to mill it, turn it, or 3D print it, basically. And then in so doing, we can choose the alignment of the component within that environment, as well as choosing the machine that's going to be used for this and the process that's going to be used for this. So if I just right-click on the setup over here and select Edit, because I've already got a setup pre-created for myself, but if we didn't, we would then go ahead and hit within the setup panel the setup tool, and this would give us pretty much the same things, just less immediately configured. So selecting Edit on here, you'll see we've got the ability to first of all select the machine that's being used to machine this particular component, whether again additive, subtractive, doesn't really matter. We've got then the ability to choose how we're going to be machining this or manufacturing this, whether it be milling, whether it be mill turn or turning, whether it be cutting, fabrication, or additive for 3D printing. And then the orientation, once we've chosen which machine and setup, we'll have different options for choosing the orientation of the model within the environment. So this is milling, and therefore we can choose which orientation it has within the machining bed itself. can then also break it down as to the model that's going to be needed to be machined. So if we are in an assembly environment, as we are in here for fixture purposes, we're just machining this component rather than all of the fixtures as well. And then if we do have fixtures, we can choose which elements are the fixtures from within here. We can then choose the size of the stock and the geometry that makes up that stock. So we've got the ability to choose either from a solid if the solid model is already created. Otherwise, we can choose between some standard shapes and sizes from within here as well. Once we've got that all set up, we can hit OK, and that will then go and start us in with that. If there is a model of the machine that you're using, this will also come in the background. It'll be saved within your project and allow you to then make use of it for simulation purposes later on down the line as well, which we will take a quick look at a little later on. But essentially from here, it's then a case of telling Fusion how we're wanting to create this component, what processes we're wanting to use to machine this. So as I mentioned earlier, the strategies we are going to be looking at are going to be extension strategies, just due to the complexity of this particular part. But the process, again, is the same throughout, whether using 2D, 3D, or multi-axis strategies. We essentially want to be able to use some roughing operations in here to clear out as much stock as we can, and then go through some semi-finishing and finishing strategies. But then again, just all dependent on the type of geometry that's required for that. So for this particular one, what we're going to start off with is a swarf, just to get some material away from the blades over here, or as much material away from the blades in a nice neat way as possible. So in the multi-axis dropdown, we do have a swarf strategy available to us. From in here, within every single strategy, again, whether extension or not, we come in and choose the tool that we want to use to machine. So selecting this, we can then have access to our library, which can be fully editable. We can add and remove tools from our library and modify them from within. For this particular one, I'm going to go for this 10mm full nose and grab it from within there. We've got a 0.5mm rad on. Get a bit of a preview once we've selected the tool as to its size in comparison to our part, which is always great to see. And we can then just eyeball just to make sure that we are happy with the sizing and that along there. From here, we can then go over to the geometry tab, where we then define what is going to be used to, or what is going to be machined as part of this particular process. And for swarfing, we need to choose the surfaces that we want to machine as part of this process. So for the drive mode, I'm going to go and use contours. You could also use the individual surfaces and let Fusion kind of calculate what's needed from there. And then for the contours, you could either choose faces once more to drive those, or use contour pairs, or manually go and select the surfaces. I'm going to use contour pairs in this particular case, and then go and choose the contours that I want aligned. And this is going to help locate where the tool needs to go down to, as well as the angle the tool needs to stick to when surfacing between these two. So it's basically going to use the two contour pairs as a bit of a rail for the positioning and rotation of the tool itself. For the contours, I'm going to use chain selection for this one, and more specifically open chain selection. So I can choose a single continuous edge along the model, something like that, rather than a closed chain. We try and find its quickest loop, which in this case doesn't work, but in other instances does work quite nicely. So for this particular one, I'm going to go and use an open chain on there, just for the bottom reference, and then another one for the top reference, another open chain for the top reference over here. I can see that's in the wrong direction, so I'm just going to go reverse the direction, and you can see based on the direction the arrow is going, which direction the tool will essentially go along that surface. So by hitting OK over there, I've got a darker blue line and a yellow line, and these will each reference the positioning. So we've got our darker blue indicating the bottom reference and the yellow line indicating. As soon as I've got that selected, hit OK on there temporarily, just to make sure that I'm happy with the way it's passing. And I'm pretty happy with that. A few adjustments I might want to make to this particular one is I'm cutting at the moment, swarfing is usually geared towards finishing operations. I'm using this as more of a roughing operation, so I wouldn't want to come as close to the surface as I am now. And I might also want to add a few steps in there just to make sure I'm not taking off as much material as I am now in a single pass. So I can right click and edit on any of the toolpaths I create to go and modify them a little further. So within the browser, right clicking and editing on Swarf over here, the area that I do want to make those changes are going to be the passes tab. So the first change I am going to make is the cutting mode. Currently it's set to a single pass. So single pass is, as the name implies, going to go and create this with a single pass along whatever references I chose. In my case, I want to have multiple passes, but using the bottom edge as the driver. So in the cutting mode, I can say I want to go from bottom. And basically what that's then going to do is it's going to go and remove any additional ones based on the offsets I choose, based on the step downs I choose. It's going to remove them from the bottom. Otherwise, blend top and bottom is often quite a nice one as well. It will then keep the same amount of steps throughout the entire process, but then slowly change the offset along the surface. But in this case, I want them parallel, so I'm going to go from bottom. Based on my selection on this, I've got a few extra options, which is the maximum step down and the cusp height. I can also do manual step downs as well if I want to. So if I want to force the step downs in there and the number of step downs. In this case, I might go and say I want formal step downs, and that goes and adjusts the cusp height, which is driven by the diameter, the step down, and the tool diameter, that is. The other option I'm going to change on this one, again, just to leave a little bit more material on this, because this is still a roughing operation, is the stock to leave. And it's going to allow me to leave radial and axial stock, which I'm just going to bump up to 1 mil each. So as a temporary option for this one, before making any fine details or fine tuning this any further, I'm just going to go and hit OK. This is going to go and calculate that fairly quickly for me, and I can see I've got 3 steps along there, and it is in fact leaving that 1 mil of material behind. So I'm happy with that on this particular one. Essentially what we'd want to do from here is then go and replicate this multiple times around the model, as many as we have blades. So this is where working within the same program for your design and your manufacture really helps, is the fact that we've now got the ability within Fusion to be able to drive the number of replications this does around the component based on the number of blades. If you remember back to our design episodes, where we've got the ability to set the number of blades as a parameter, we can actually make use of that parameter to drive how many blades we actually manufacture. So I can go in and create a replication of this toolpath inside of the model based on the number of blades that are required against this component. So to do that, I can go into my setup dropdown and create a pattern folder, which is basically going to pattern any toolpaths that are within this folder. And the pattern types that are available to us are linear, circular, mirror, and duplicate. In this case, we want to create a circular pattern, a full 360 degrees around. The default number of instances is 2. But again, I've got that parameter in here, so I can just say blades, which was the number of blades. You can see it picks that up as a parameter in here, as a design parameter. And therefore, however many blades I have, that's how many times it's going to replicate this around. So fairly simply, choosing that I want a circular pattern rather than any other type to create a circular pattern. The number of instances I want there and the angle around there. And then the axes that's required for the rotation itself. In this case, this can be any circular reference that has the same center point, same center line and axes, which can be either of these 2 faces over here. As soon as I hit OK on there now, this will create that pattern. Currently, the swarf isn't inside of that pattern yet, hasn't been used within that pattern, but I can rectify that simply by dragging and dropping swarf from where it currently is into the pattern itself. And now I have 3 instances of that swarf all the way around. So I won't go through that same process for all of the others. I'm going to do quite a few of them that are replicated, and at the end I will show you a completed version that we've created offline as well. But I'll just show you step by step through some of the strategies that we're going to be using for the creation of this part as we go to the manufacturing facility later on down the line, and hopefully. Through the magic of editing, you've got some video feedback as well as to the final finished part being made later on down the line as well. So with this one, the next step we'll go in and add is the ability to clear out a bit more. So now we've cleared out a bit on that blade over there. We want to go and rough out a bit more stock everywhere else on the component. So another option that we do have within the multi-axis functionality is a rotary pocket. And this is an extended functionality. A similar option you might want to look at if you aren't using the extension is the adaptive clearing. The adaptive clearing, 3D adaptive clearing especially, is going to take away a lot of stock from the top of this part and work its way down into it. So that's a really handy one. But because I'm using some multi-axis functionality, because we do have a 5-axis capable machine, we want to go and make full use of that for the creation of this. So using a rotary pocket, this is essentially going to allow us to take in the angle of the part, looking at the center of rotation, and it basically allow us to then pocket out the component as we go through. So using the same tool to begin with, just to start and rough out as much as we can from here. In the geometry tab, I am going to also enable rest machining, which is just going to ignore any areas that we have potentially machined already or we have machined already. And this is going to look at the previous operation. So it's going to look within the swarf, see where that swarf touched, and essentially machine anything else essentially from there. For the most part, on this particular one, the only thing I am going to go and adjust, just as a quick overview on this one, is within the passes tab. I'm going to leave the same amount of stock behind. So I'm just going to try and clear out as much of the stock from within this area as we can. So hit OK on there now, and this will go and generate that rotary pocket toolpath. Should go all the way around it, spinning the center of the part around the center of axes that has been set up in the setup, and basically machining as close as it can get to those surfaces while keeping within our 1mm limitation on there. So this is going to carry on for a few seconds and just begin to go through that process. What I am going to do is I'm going to duplicate this just to go a bit finer on here as well. So we've got one roughing, and then we've got one sort of semi-finishing pocket that we're going to go and add in here. So by right-clicking and selecting duplicate, I can take the exact same setup that was in that particular one and just go ahead and change the tool that's going to be used. So I'm going to drop this down to maybe we want a 10mm on that particular one. I can drop this down. There's a 4mm over here as well, which could be a good one, which should get us a little bit closer to the surface on there. And then maybe for the stock to leave, I'll drop that down to 0.75 just to make sure that it is actually taking a bit of material off of that as well. Probably drop that to 0.5, but I want to leave a bit more stock for other tool paths to get in there and just to get a bit of a better finish on there as we go through. But if I go and select the rotary pocket option over here, the original one, you can see the toolpath it's gone and created. So keeping the center of the part as the center of the toolpath, and then just rotating around, going along the Z axis of the setup as it is. So it will leave behind a bit of stock over here, which I do want to come in with the smaller tool to finish off, which is currently generating the toolpath at the moment. I'll leave that to generate as it goes along there. The next element I do want to come in and adjust is going to be, or the next surface rather, I want to go and machine is this pocket area over here. So with another smaller tool, probably not a bull nose, but maybe a ball end, I want to go in and use one of the newer toolpaths, which is the geodesic toolpath. So this is available also in the 3D dropdown, but this is part of the manufacturing extension. We can go in and choose ball end mill, probably to begin with the 6 mil and see how we get along with that. With this one, for the geometry, we can go and pick a surface that we want to go and machine. In this case, I'm going to go and drive it with this surface over here. And this is essentially just going to go and choose either to create sort of parallel blended passes, or scallop, which is going to go and take the perimeter of the surface and then just add passes in around that perimeter, which is quite a nice one to use on this particular one. If you are struggling to get the exact references, there are a few different ways we can begin to change the machining boundary, whether by picking a silhouette, whether by picking an exact surface. And then also with the machining side, currently I've got that set to automatic, but if you'd like to do the other side of the surface, you can do so. You can also offset the passes, either using the boundary, so you can make sure that the passes are offset using the scallop to offset from there, or follow a particular center line as you go through, and a few variations we can have on. The other thing I might want to adjust on here again is the passes, leaving a bit of stock on here. Again, I'm going to go for 0.5 mil on this particular one. As this is going to be a semi-finishing, we'll come in with a final finish a little later on. And then the maximum step over, we could probably reduce this currently on a 6 mil tool. So currently I had 3 mil step over. I might want to drop this down to 2 for now. Again, semi-finishing, not quite finished yet. But as soon as I'm happy with that, I can hit OK. We can just see how it deals with that. We've got our rotary pocket that has been created as well, which has added a lot more toolpaths in there and cleared out quite a substantial amount from that area on the inside over there. Let's have a look at this geodesic at the moment, and you can see that at the moment it's trying to machine from the top, which is the default direction, which is all good and well with this current setup. Or as it is currently set up, but I don't necessarily want to do this. This is using 3-axis machining. I want to enable the ability to handle this with multi-axis. So I'm going to right-click and edit on this particular one, and then we've got a multi-axis tab available to us. Within that, I can go and say, actually, machine this as if this were a, or calculate this based on a 4-axis setup. The rotary axis is going to be the Z axis, so it is going to be the one that is within the setup itself. Go and hit OK on there now, and we should see a slight change in the way it calculates that toolpath, which is really nice. So again, this is a bit of a semi-finishing, and then we would go and duplicate this 3 times around just to make sure that it is doing what we need it to on there. Next steps would then be doing a few more finishing operations or semi-finishing operations on each of the blades, and then replicating them around once more. So similar process as the last one. On this particular one, we're looking at going for a geodesic finish on the surfaces here for both a semi-finish and a finish. So using the same strategy, but again, on this particular one, a smaller tool. So for the semi-finishing, probably the 6 mil again, just to get a bit more material off there. But for finishing, dropping it down to a 4 mil just to get nice and tight on there. In the geometry tab, once more using the surfaces to kind of drive how this wraps around the blade. So selecting all of the surfaces that we want machined as part of this process, including the fillets on the bottom over here, just to get a nice blend from the blade all the way down into the main surface of the model. Also potentially using a scallop on this one, and then enabling 4-axis strategies just to make sure it's getting nice and neatly in from the side of the part. In the passes tab, dropping the step over down a bit, depending on size of tools and the like. So just as a very quick one on this one, having a look and making sure that we're happy with the way that's getting around there. And I'm quite happy with the way that's tracing about on that surface over there. And then again, the case of basically repeating that for the larger blade. I won't go through the process of adding that in because it's pretty much the same from there. Then as a bit more of a finishing operation, which I think is probably worthwhile just showing in the finished component, is then coming in and finishing off not only the top over here, with a 0 mil step over just to make, 0 mil stock to leave just to make sure we're right down to the final finished surface. But then also coming in with another bit of functionality that's been added into the manufacturing extension fairly recently, and that is a deburr strategy, which is going to approach any sharper corners along the way. So I'll quickly just switch over to this Impeller V3 over here, which is the one with all of the toolpaths in. And though it might be quite a lot of toolpaths in here, you can see it's pretty much the same process as I've gone through on there. So starting off with a circular pattern that is using, in this case, an advanced swarf, but the regular swarf is doing pretty much the same thing. But then it's just replicated 3 times around to get that initial pass on the larger blade. We then have the rotary pocket with the 10 mil tool that's going in machining the entire toolpath, or the entire part as much as it can into as deep of the pockets as it can, obviously avoiding some of the surfaces in there. But those are then picked up with a secondary rotary pocket with a 4 mil tool, which gets a lot closer in there and gets a little bit further along in the finishing process. Then a semi-finish on the surface over here using the geodesic toolpath or strategy rather. You can see with a little bit of stock left behind on there just to make sure we're not machining the final finished surface in there, but the surfaces are being machined as it goes through there. I've got another semi-finish on the smaller blade, and then another semi-finish on the larger blade, and each of those have then been replicated multiple times around the component using the pattern functionality from within there. That's then repeated one more time, with the same tool, but just with less stock to leave at the end, just to make sure it's getting really, really close to that surface. And we can see on this geodesic over here, it's not giving me a preview just yet of the stock. I think it's still trying to generate the stock in the background. I can see these are still loading over here, but essentially giving us the ability to go and get that machined nice and close to those blades. Then we have gone in and added a flat up at the top over here just to make sure that doesn't have any excess material at the top and is ready for a drill later on down the line in a separate operation. We then also have a steep and shallow strategy, which is just going to go and attack these surfaces over here, making sure that we get a nice neat finish along the perimeter or along the cylinder of the model. And then the final strategy is the deburr, which is then just going to go along all of the sharp edges along the model and basically machine those off for us, just to get rid of any swarf that might be left behind. Cool. So with that, we can then essentially go and simulate all of this. So this particular model has been set up with a machine, and that will allow us to look at machining simulation just to make sure that our component, our part that we're designing, will be machinable within the machine itself, within the cutter or the printer or whatever method we're using to create this. It's going to look at the kinematics of the actual machine itself, just to see the limitations in rotation and movement within the model itself. So if I go and grab one of the ones that is a really nice one to have a look at is this advanced swarf over here, but I'll go and simulate the pattern. So I can either right click on the individual toolpath, I can right click on the pattern, or I could right click on the entire setup. This is quite a heavy one. I don't want to load my machine too much while I'm recording, so I'm going to go and do a few of them at a time. So I'm going to right click on the pattern over here and then choose the option to simulate, but simulate with machine. This is going to place my component in the machine itself. Let me rotate this model around just a little bit just to get a good view of this. Something like this should be good. And then I've got the ability to enable the visibility of stock and start simulating this throughout. So we can see at the moment I'm following the tool along just to see how that's going to be machining around the component. But I can also change my view, rather than being focused on the tool, is to actually look at this based on the machine itself, the machine base, and looking at this from a bit of a isometric view. I can then view the model as the tool the bed and bed table are moving. We've also then got the machine itself doing its movements as well, which we can begin to analyze as we go through. I'm viewing this from the front, or the bottom of the model according to the view cube, I suppose, but we can see this now as it's going through these. And again, hopefully you guys can see those side-by-side comparisons of what was actually machined when we get there, and what the simulation is showing as well. If I exit out of this one and quickly have a look at maybe some of the semi-finishing, actually the rotary pocket is quite a nice one to have a look at as well. Also within the simulate with machine, just to get a nice view of this. And we can have a look at some of the simulation options that are available to us and colorizations against that. So if I go ahead and play this, we can see this coming in and actually going in and rotating the model as it goes around and begins to machine this out. As far as the stock visibility options that are available to us, we've got the ability to either have it as a solid material, so we can actually see the material being machined away from here. We can choose the type of material we're looking at for reflectivity and the like. We can also change the color to operation, so we can see which operation touches which surfaces along the way. And we can then better identify any changes that might need to be required or might be required against the toolpath itself, and similar for the tool, so we can see which tools make contact with which surfaces. In this case, we're just looking at a single one, but we would see it change color as the operations go along. But another really handy one is the comparison one, which will show us in green any of the surfaces that are at their final finished height. Blue will show us anywhere where we have remaining stock, and then red will show us where we have a collision, or where our tool has gone through a portion of our part, which is collision. We can also then speed this up a little bit and have a look at this going all the way around, and you can see it's changed the rotation a little bit over there and going backwards on itself. If I slow this down a little bit but skip a little bit further along in the timeline, we can see as it gets a bit further along in the process, and starts to machine this out using the rotary pocket. The last one I'll have a quick look at, but rather than doing a full-on machine simulation, although this one does look pretty impressive with the machine simulation, I will just do a normal simulation on this one, and we can see how the geodesic is calculated through here. Interestingly, the in-process stock isn't quite what we would expect it to be. It's just using the default stock that was in the setup itself, but we can then begin to see how this geodesic is going to work its way from the top of the blade all the way down and take away material. Ignore the collision for this particular one because, as I say, the stock hasn't been generated correctly for some reason. But this is essentially how we would then go ahead and machine this. I'm going to stop when it collides with stock option. So disable stop on collision quickly. We can then just see this working its way around the perimeter over there. And then the last one again is the debo, which is very impressive. I will simulate this one with the machine just so you can see the full working of the machine as it goes through its various processes. Let me just rotate it around just to get a good angle on here. We can then begin to see as it gets around this component. I'll ignore the stock again, this one. We can see with the machine base still the estimation on how this is going to go about machining this. Awesome. So that's essentially the process involved in creating these. So again, taking our designs, especially if they are designed in Fusion, this is going to help speed up a lot of the processes, as you saw with the ability to grab the number of blades that are within the model and let that drive. We can also have various other parameters driving any of the inputs that come along there. So whether it be a offset value, whether it be a step over, whether it be a stock to leave, we can then have all of those drive or be driven by parameters within the model itself, which is a really handy one to have, including, I suppose, the ability to have fillets. You can have rads and nominal rads, maximum rads, and the like in there, which can then start to drive things in the manufacturing side of things. But just being able to take a design that's been made inside of Fusion and push the results of that straight out to the machines themselves. And even before that, being able to simulate this, make sure that we are going to be getting the results that we require on this. And just being able to establish if the toolpaths look fine, but still wanting to be able to ensure that in the simulation environment it's not found any collisions that we weren't expecting based on just the toolpaths being able to identify that not only in the part but also in the machine as a whole. So being able to add all of this information in. Again, for the most part, the only additional functionality that was in here from an extension perspective were the strategies themselves, but the process is the same throughout. We've got the ability to do machine simulation. We've got the ability to do simulation. We've got the ability to add stock and run comparisons to that. So there's a lot of functionality right within the base of Fusion, but then we do have the ability to extend that further with the manufacturing extension if you are looking at doing slightly more complex multi-axis toolpaths in here. It's a great addition to the package as a whole. But that's essentially all we wanted to show for today. Again, hoping the videos have come through quite nicely, especially as we've gone ahead and manufactured these as well. We can have a bit of a side-by-side comparison for some of these. But yeah, that's all we really wanted to go through for today. So until next time, bye for now.